my microorganism is Vibrio harveyi, which is a marine bacteria. It's a member of the genus Vibrio in the family Vibrinaceae, order Vibrinalis, class Gamma Proteobacteria, and the phylum Proteobacteria. It's pretty genotypically and phenotypically similar to Vibrio campbelli. It's gram-negative, bioluminescent, rod-shaped, and it has polar flagella to use for its motility. It's a facultative anaerobe and is able to use different carbon sources for its metabolism. It lives in multiple niche environments, which is the reason that it's able to use different carbon sources depending on the availability. And this can be both in a pathogenic, symbiotic, or it can also be a planktonic bacteria, actually. Within the squid, it forms a symbiotic relationship, which is what you can see on the screen right now. The bacteria lives inside of the light organ of the squid and provides the bacteria with nutrients in exchange for its bioluminescence, which the squid then can use to attract prey, as well as it uses it also for camouflage in the moonlight as well. And once the bacteria is settled inside of the light organ, it will stay there throughout the lifespan of the squid. So usually bacteria enters during the time where squids are juveniles, and then the rest of its lifespan, they're doing their thing inside of the squid. And when there are not a lot of options for this bacteria to be planktonic or be in any kind of symbiotic relationships, it does become more virulent and searches for a host to be pathogenic, and eventually will kill the host as well. And because of that, it's becoming increasingly more dangerous marine bacteria. It's been around for a long time, but because of global warming, the temperature of the waters are rising, and this bacteria really likes warm water. It started out in tropical waters, but has since spread all across the world. You can find it in areas in Europe now, in Asia, where it's a huge problem as well. And this is a big threat to our food industry. An example of that is the shrimp in Asia. So the bacteria can cause multiple different diseases, including eye disease. It can cause gastroenteritis, and in case of the shrimp, luminous vibriosis. And luminous vibriosis is pretty recognizable since it actually makes the host glow, which is a pretty obvious thing. And that's because the V. harveyi is inside of the stomach, and it uses the chitinous lining of the stomach as the carbon source for its metabolism. So that's what's going to make it glow, especially in the abdominal area. And that will kill the shrimp. The shrimp also start swimming in all kinds of different directions. There's just all kinds of really sad things when they are infected with this bacteria. And this is really hurting shrimp farmers as well. So there's a huge demand in the world for shrimp. It's a big industry, and over the years, aquaculture farmers are losing more and more money each year on these different diseases that are plaguing the shrimp specifically, and of course, other industries that are plagued by this bacteria and its relatives as well. So a lot of the times in aquaculture farming, one of the main ways to prevent things like this and to treat the product, I guess, the shrimp or the whatever else I guess you're farming, is using antibiotics. But as we know from lots of different industries, and also just from our world and antibiotics for humans, there's more and more antibiotic resistance that seems to be popping up all over, which is why they're trying to find a different, more creative solution that could be not related to antibiotics, and also just that there's a demand from people for their food to not be raised with antibiotics. So that's another big motivator for that as well. The bacteria never really grows bigger than the size that it starts at inside of the squid, as going with my squid example, I guess. It stays in there, it grows, it bioluminesces, and some of it, as as the population grows, some of it does get released into the water, but in general, the major colonies stay inside of the squid.